So, good morning, dear students. Myself, Dr. Lingaraju, Assistant Professor of Physics, Government First Degree College, Tumkur. Our college is affiliated to Tumkur University. So, today we'll discuss in polarization of light concept. We'll discuss polarization. So, these concepts will be in BSc Physics subject, 4th semester, session number 40. So, it is a optic concepts. This polarization already we discussed. We studied in PUC. Interference, diffraction, polarizations. All this due to a light effects. So we are going to got it from electromagnetic radiations. So in the next step, how many types, what are the factors, importance, features, characteristics, everything here we are going to study. So first we come to the polarization of light. Usually we know polarization means polarize the content. It means it should be moves in a one order, one directions, in status. So that one is we are going to call as a polarization. Polarization in physics, it is defined as a phenomenon caused due to the wave nature of electromagnetic radiations, that is EMF, electromagnetic radiations. So sunlight travels through the vacuum to reach the earth, which is an example of an electromagnetic wave. So are called electromagnetic waves because they form when an electric field that interact with a magnetic field. Here you will learn about two types of waves. One is a transverse waves, another one is a longitudinal waves. So here we know in PUC only we studied. Once again we will recall these two. Transverse waves are waves, that is movement of the particles in the wave is perpendicular to the direction of motion of the wave. Transverse waves is movement of the particles in the wave perpendicular to the direction of the waves, perpendicular to the direction of the motion of the waves. That is ripples in water when you are throw a stone. The motion of a sound waves through the air. These are a transverse waves. So longitudinal waves. Longitudinal waves are when the particles of the medium travel in the direction of motion of the waves. Longitudinal waves are when the particles of the medium travel in the direction of the motion of the waves. Light is the interaction of electric and magnetic fields traveling through a space. Now here you can observe it. The electric and magnetic vibrations of a light wave occur perpendicularly to each other. The electric field moves in one direction and magnetic in another through always a perpendicularity. So knowing this, so we have a one plane occupied by the electric field. The magnetic field perpendicular to it. Electric field, magnetic field perpendicular to it. And the direction of the travel which is perpendicular to both. These electric and magnetic vibrations can occur in numerous planes. A light wave that is vibrating in more than one plane is known as unpolarized light. In one plane, light waves will be moving in a different order, different plane, that is we call as unpolarized. The light emitted by the sun, by a lamp or a tube light are the all unpolarized light sources. unpolarized light sources. Just we can imagine or observe in a diagram. As you can see in the image, the direction of propagation is constant. The direction of propagation, you see, direction of propagation is constant, but the planes on which the amplitude occurs is changing. The planes on it, you see, the amplitude occurs on it is occurs changing. The image here shows its various types. So it is rotating in this type. So such kind of radiations are we called as a unpolarized light radiations. These unpolarized light radiations will be moves through any one kind of a polarizers. Through it, the other kind the wave is polarizes. Through it, other kind the wave is polarized. Polarize, you see, how polarizing, you see, here horizontal is there, transverse is there. So like that, all the vertical, everything will be moves in this way, but here only one type of radiations will be comes out. That is polarized light. So that is the thing. The other kind of wave is polarized. Polarized waves are light waves in which the vibrations occur in a single plane. Plane polarized light consists of waves in which the directions of vibrations is the same for all waves. In the image above, whatever the explained reason, you can see that plane polarized light vibrates on only one plane. The process of transforming unpolarized light into polarized light is known as polarizations. Did you understand this concept? The process of transforming unpolarized light into polarized light is known as polarizations. The device like the purple blocks you see are used in the polarizer of light radiations. Purple block used in the polarized light radiations. Next, definitions of polarizations. The phenomenon in which the vibrations of electric field vector of light waves is confined to only one particular directions perpendicular to the direction of propagation of wave is called polarization of light. Once again I read, a phenomenon in which the vibrations of electric field vector of light waves is defined to only one perpendicular direction perpendicular to the direction of the propagations. Wave is called as only one kind of waves will be moves, either transverse or longitudinal. That is we call as a polarization of light. The light in which vibrations of electric field of light waves confined to only one particular plane perpendicular to the direction of propagation of wave is called plane of polarized. Light or linearly polarized light are simply polarizations or polarized light. You see, the representation of vibrations of light. You see, here two types of vibrations are there. The dots is one type, the straight lines are one type. That one is combining with a one wave, so it is we called as unpolarized. Here you see, unpolarized, here only the one type of radiation will be moves. So here it is a unpolarized light. So plane polarized, you see they are having a different distances, the different distant angles. So here with the vibrations parallel to the plane of the proper. Here the vibrations parallel to the plane. That is we call as a plane polarized. Plane polarized light with the vibrations perpendicular to the plane of the papers. It is also plane. This is also plane. This is also plane. But here you see partial. Here one kind of radiation. Here one kind of combined. So like that. So it is partially polarized. Here somewhat polarization. Another one is polarization, but it is unpolarized. So like that here we can observe the diagrams. So plane of incidence. Incident ray, reflected ray, refracted ray and normal. Two incidence form plane. That plane is a plane of incidence. Plane of vibration and Plane of polarizations. When unpolarized light is passed through a tourmaline crystal, unpolarized light, the emergent light is plane polarized and vibrations of electric field confined to a single plane. The electric field vector vibrates perpendicular to the direction of the propagations. The electric field produced of these vibrations of a wavelength perpendicular to the direction of the propagation. That is we call as plane of vibrations or plane of polarizations. So plane of vibrations. The plane in which the vibrations of electric field vector of a plane polarized light takes place is called plane of vibrations. The plane in which the vibrations of electric field vector of a plane polarized light takes place, represented by a plane ABCD in the plane paper as shown in the figure 2. Okay, see in this diagram whatever the concept we discussed, you can see. So in the plane in the 2 diagram, figure 2. So what it explains? The plane in which the vibrations of electric field vector of a plane polarized light takes place is called the plane of vibrations. So next, the plane of vibration also contains the direction of propagation of light. The plane of vibration contains the direction of propagation of light. ಯಾವ ಡೈರೆಕ್ಷನ್ ಕಡೆ ಅದು ಹೋಗುತ್ತೆ ಅನ್ನೋದನ್ನು ನಿರ್ಧಾರ ಮಾಡುತ್ತೆ. So plane of polarization, the plane passing through the direction of propagation and containing no vibrations is called the plane of polarization. So here you can observe representation of plane of polarization and plane of vibrations. You see, the source, from the source unpolarized light will be enters in the Nicol prisms. So the light will be gets polarized. So now here we can consider is A, B, C, D one wave. So A dash, B dash, C dash, D dash, D one more another plane polarized light radiations. So now here that is the way the plane polarized light radiations will be comes out. Following are the 3 types of polarization depends on the transverse and longitudinal wave motions: linear polarization, circular polarization, and elliptical polarizations. So here methods used in the polarizations of light. Methods used in the polarization of light na ತಗೊಳ್ಳೋದಕ್ಕೆ. Methods used in the polarization of light is reflections, refractions, transmissions, and scattering. So these are all the 4 things. If a linearly polarized wave is incident on the interface of 2 dielectrics with an angle of incidence equal to theta. If the angle of incidence theta is such that theta is equal to OP, that is equal to tan inverse of N2 by N1, the reflection coefficient is 0. So thus, if the unpolarized beam is incident with an angle of incidence equal to theta p, the reflected beam is plane polarized. Reflected beam plane polarized ಆಗಿರುತ್ತೆ, whose electric vector is perpendicular to the plane of incidence. So now here we know Bristol's law. At an angle of 45 degree, the light radiation will be gets reflect. That is Bristol's law. So the angle of theta p is known as the polarized angle or Bristol's angle. At 45 degree ನಲ್ಲಿ ಅದು reflect ಆಗುವಂತ conditions explain ಮಾಡುತ್ತೆ. At this angle, the reflected or refracted radius are at right angle to each other. Right angle to each other. That is theta p plus r is equal to pi by 2 is equal to n is equal to sin theta p by sin r. That is equal to sin theta p by sin, that is cos theta p, that is equal to tan theta p is equal to n. So here air glass interface n is equal to 1, n2 is also 1.5. So of knowing that how the polarization will be produced by refractions. If an unpolarized beam is incident with an angle of incidence equal to theta p, The reflected beam is plane polarized whose electric vector is perpendicular to the plane of incidence due to the refractions. The transmitted beam is partially polarized, and if this beam is made to undergo several reflections, then the emergent beam is almost plane polarized with the electric vector in the plane of incidence. So, where if IP and IS are parallel and perpendicular to the component of reflected light radiations. Here we can observe it. Polarized by refraction. Unpolarized light radiation will be incident to the nickel prism at an angle of Transverse. Then it gets the reflections. Now here we can observe two types of radiations will be observed from the nickel prism. This is the ordinary light radiation. This is the extraordinary light radiations. So due to that one can get it polarized light radiations. Polarization by the selective absorptions. A simple method of eliminating one of the beam is through selective absorption. This property of selective absorption is known as dichromism. A crystal such as tourmaline has different coefficients of absorptions for the two linearly polarized beams into which the incident beam splits up. Consequently, one of the beam gets absorbed quickly and the other component passes through without much attenuations. That is the way of absorption. We can get the polarizations. You can see a selective absorptions. Unpolarized light radiation will be incident on a transmission orientations. So then the light radiations will be comes out in a partially polarized light radiations. Through another transmission, we are getting a select polarization by a selective absorptions. So thus, if an unpolarized beam is passed through a tourmaline crystal, the emergent beam will be linearly polarized. The emergent beam, you see, from here it is going to emerges, will be get linearly polarized. After knowing this thing, so polarization is also produced by the double refractions. When a ray of unpolarized light passed through a doubly refracted crystal, that is a calcite, something like a quartz on glass, it splits up into two refracted rays. One of the ray obeys the ordinary law of refraction and this is called as ordinary ray. One more another behaves like an extraordinary ray, it is also called as an extraordinary ray. So these two are behaves like a polarizations. It is found that both our ordinary and extraordinary rays are plane polarized, having a vibrations perpendicular to each other. If one can sandwich a layer of material whose refractive index lies between the two, then for one of the beam's incidence will be at a rarer medium and the other will be at the denser mediums. So here we know the principle of use of nickel prism, which consists of a calcite crystal cut in such a way that a beam for which a sandwiched material is rarer medium, the angle of incidence greater than the critical angle. Knowing this, the particular beam will be eliminated by a total reflections. So this extraordinary component passes through and then beam emerging out from the crystals is just linearly polarized. So you can observe it. Unpolarized light radiation will be inserted to the plates. So here plane polarizer one direction, one more another plane polarization in other directions. They will be getting that is due to a double refractions. That is due to double refractions. Polarization will also get or exist or produce due to a double refraction of a glass plates or quartz plates or calcite plates. Scattering also we can produce as polarization. When an unpolarized beam is moving in a z-axis, strikes a gas atom, then the electric field is unpolarized beam, sets the electric charges in the gas atom in vibrations. Since the E field is in xy plane, therefore the vibration will take place in xy plane only. Then since the oscillating dipole does not radiate in the direction of its own length. So we can observe it here. That is a scattering. Therefore, observer along x-axis will be receive light component vibrating only in a y directions along y-axis. The component will be vibrate only x-axis. Hence, observer will receive a plane polarized light. You see, from the sun, unpolarized light will be going to incident moving through a air molecule gets double reflections. So double reflection scattering, the scattered light radiation becomes out in the form of a plane polarized. In the air molecule ಜೊತೆಗೆ interaction ಆಗಿ scattering ಆಗುತ್ತೆ. Scattering ಆಗಿರೋ light radiation will be gets in the form of polarizations. That is due to polarizations. Blue color of sky. So here we know Lord Rayleigh formula, intensity of light scattering from free particles varies inversely as a 4 power. Scattered intensity of a blue light is more than red light. Lambda blue is less than red. Lambda red. Why blue scattered more? Naturally, frequency of bound electron in a gas lies in the ultraviolet regions. Blue light are closer to natural frequency than the red light. That is the reason. Therefore, blue is more effective in causing the electron to oscillate, and thus it gets more effectively scattered than red. So far, if you observe the sky, it is look like a blue color. Red color is of sunrise and sunset, but in the sunrise and sunset, it is like a red color. The path of the light through the atmosphere at sunrise and sunset is greatest. Since violet and blue light is largely scattered to get removed, and what is in rest having a red component. So following are the applications of the polarizations. Polarization is used in sunglasses to reduce the glare. Polaroid filters are used in plastic industries for performing stress analysis tests. One-dimensional movies are produced and shown with the help of polarizations. Polarizations is used for diffractionating between transverse and longitudinal waves. Change ಮಾಡೋದಕ್ಕೆ polarization use ಮಾಡ್ತೇವೆ. Infrared spectroscopy uses for polarizations. It is used for seismology to study the earthquakes. So in chemistry, the chirality of organic compounds is tested using polarization techniques. So all these concepts I have referred using a Sundararajan and also Subramanian reference books. There are also 3 different prescribed textbooks referred from the Tumkur universities. So it's about the polarization of light. Thank you.